Dr. Abba Singh, a nanofossil researcher from Birbal Sahni Institute of Paleosciences, India. My research interests are Mesozoic and Cenozoic calcareous nanofossil biostratigraphy and paleobiogeography, paleoecology, and paleoenvironmental studies based on coccolithophores, which are also called calcareous nanofossils or nanofossils. In India, nanofossil studies started in 1963 when T. Narasimhan from Indian School of Mines, Dhanbad, Jharkhand, has recorded Maastrichtian and Dannian age nanofossils from sediment of Khasi Hill, Assam, Northeast India. In this study, he has recorded a new species called Coccolithus reticulatus. After that, in 1969, S.C. Pant and B.D. Mamgain has published nanofossils from northwestern and southern part of India, which is from Jurassic of Hazara, Cretaceous of Trishnapalli, and Eocene to Miocene aged sediments of Kutch. And they have also provided the systematics of the recorded nanofossils from all three areas. From 1970 to 1990, nanofossil studies became common in India, and these studies were carried out from Jurassic, Cretaceous, Paleogene, Neogene, and Quaternary age sediments of Tethys Himalaya, Jaisalmer Basin, Kutch Basin, Cambay Basin, Narmada Basin, Arabian Sea, Bombay Offshore Basin, Kerala Konkan Basin, Kaveri Basin, Southern Ocean, Bay of Bengal, Krishna Godavari Basin, Meghalaya, Mizoram, and Andaman and Nicobar Islands. In India, the major nanofossil studies were carried out by a small group of 2-3 researchers from the few prestigious organizations like National Institute of Oceanography, National Center for Polar and Ocean Research, Keshwadeva Malviya Institute of Petroleum Exploration, and Birbal Sahni Institute of Paleosciences. The studies on extant and extinct coccolithophores from India has a long list, so only few of them are going to be shown in this video. From National Institute of Oceanography, Dr. M.V.S. Gupta has published a sequence of papers from 1973 to 1995 on late Miocene to early Pliocene, late Pleistocene, and recent age nanofossils from Kutch, Andaman and Nicobar Island, and continental shelf of Arabian Sea. In 2006, he has reported few more coccolithophores from the Arabian Sea and Bay of Bengal. This study was on coccolithophore fluxes from the sediment trap samples in the central Arabian Sea, and they showed enhanced fluxes during northeast monsoon as compared to southwest monsoon. In recent years, Shramik Patil from National Center for Polar and Ocean Research has published few papers on coccolithophores from Southern Ocean and have reported a new species, Calcisonia subtropicus, based on energy dispersive spectrometry. This new species revealed a high concentration of silica in the body coccoliths, which appear dark, and whereas negligible silica in the apical coccoliths, which appear brighter under cross-polarized light. Such a combination of silicon and calcium is rare in coccoliths. From Keshwadeva Malviya Institute of Petroleum Exploration, Qazi Asad Ali has published early Cretaceous hot Trivian age nanofossils from the subsurface sediments of Kaveri Basin, in which he recorded Cystogygous striatus, Crucilapsis cuvelleri, and Spectonia colligata. This study signifies that in Kaveri Basin, marine incursion took place in early Hottrivian rather than Aptian Albian as suggested by the earlier studies based on the foraminifera from the exposed sequence of Cretaceous in the basin. And from the same organization, Rajesh Kumar Saxena with Katharina von Salis has published calcareous nanofossil across KT from the Krishna Godavari Basin of southern India. The study includes the interval above, within, and below the Deccan Trap. They showed presence of upper Maastrichtian below the trap, presence of KT boundary within the trap, and presence of Dannian sediments above the trap. Based on the nanofossil study, they have also reported that the span of volcanism has probably not lasted more than 4 million years in Krishna Godavari Basin. In India, major work on fossil coccolithophores is carried out by the researchers of Birbal Sahni Institute of Paleosciences from 1981 to present by Dr. Saeed Abbas Jafar, Dr. Rahul Garg, Dr. Josna Rai, myself, Dr. Arindam Chakravarti, and Dr. Premraj Udandam. Dr. Saeed Abbas Jafar, Dr. Josna Rai, and myself individually and together published a list of papers on calcareous nanofossils from almost all the Indian marine basins and in age from Triassic to Quaternary. From the BSIP, major papers have been published on the biostratigraphical aspects of calcareous nanofossils and few on the other aspects also from late Triassic to Quaternary. In India, only one late Triassic Norian to Rhytian age nanofossil record was found from the Neothethian sediments of Indus Sangpo suture zone of Ladakh, Himalaya by Dr. Josna Rai. This study was published by me and it signifies the potential of nanofossil studies for biostratigraphy. In this study, ammonoid poor lower part of the lower member of Spiti Formation is precisely dated as Caluvian age. Earlier, the whole sequence of Spiti Formation was dated as Oxfordian to Tithonian based on ammonoid and dinoflagellate cysts. This study demonstrates the presence of reworked Pleistocene, Taurasian, and Alanian age calcareous nanofossils from the Bajocian strata of Lathi Formation, Jaisalmer Basin, Western India, and it suggests that the Epiric sea transgress took place in Western India during the early Jurassic rather than earlier consideration of Middle Jurassic. This work is published by Dr. Saeed Abbas Jafar, and the purpose of showing this work is to present the usefulness of calcareous nanofossils in calibration of the various Cretaceous sequences from different marine basins of India and their evolution through time, with a special reference to the presence of global nanofossil zones established in various basins. Again, this work is published by me, and in this work, cluster analysis was performed on the latest Maastrichtian nanofossil assemblage to show the paleodepositional environmental changes within the Macula Prince's zone. In the lower part of the section, the abundance of Macula concava, Macula staurophora, is stressful condition with low productivity in surface water. However, in the upper part of the section, the increased number of Calculatus obscurus with the decrease in Macula concava and Macula staurophora abundance indicates relatively increased productivity in surface water in marginal marine depositional environment. This work is published by Dr. Rahul Garg from Northeast India, shows the record of diagnostic latest Maastrichtian calcareous nanofossil assemblage belonging to Macula Prince's zone, reported below the iridium-rich clay layer. This study confirms that only the existence of the youngest Maastrichtian in this section, but also suggests demarcation of KT boundary. This review work is published by Dr. Josna Rai and it shows occurrence of nanofossils in Paleogene sedimentary succession from several sedimentary basins of India. Available dataset demonstrates that nanofossil evidence has proved to be crucial for precise demarcation of time boundaries like Maastrichtian Danian, Danian Selendian, Thanatian Viperian, Viperian Lutetian, Lutetian and Bartonian Trabonian based on nanofossils. This work is carried out by Dr. Josna Rai and myself. In this work, a fairly rich and moderately diversified nanofossil assemblage was recorded from the subsurface sediment of Jaisalmer Basin, Western India. The presence of Crabocentrum reticulatum and Discoaster sapinensis in this nanofossil assemblage suggests NP17 nanofossil sapinensis zone of Bartonian age. In this study, myself, Josna Rai, and Dr. Rahul Garg have recorded calcareous nanofossil assemblage from Meghalaya, Northeast India. Presence of Femma papillatum and absence of Crabocentrum reticulatum recovered from this assemblage suggests late Eocene Crabonian age. Before this work, the sediments of Havelock Island have been dated from early Miocene to late Pleistocene based on planktic foraminifera biostratigraphy. The present analysis on calcareous nanofossil suggests latest earlier Miocene to earliest middle Miocene, Burdigalian to Langian age for the sediments based on the presence of Spinolithus heteromorphus, a characteristic form of NN4 zone. The present contribution by Dr. Arindam Chakravarti provide a study of calcareous nanofossils from the Savai Bay Formation on Car Nicobar Island, Northern Indian Ocean. The calcareous nanofossil index taxa, Ceratolithus armatus and Ceratolithus cristatus, indicate presence of NN12 and NN13 zone of early Pliocene age. Holocene calcareous nanoplanktons were recorded by Dr. Premraj Uddandam from the surface sediment samples of Northern and Western Bay of Bengal. The regional differences in nanoplankton assemblage were recorded. The sediment samples from Northern Bay of Bengal showed very low abundance of Emiliana hexley and Gepharocapsa oceanica, indicating very low productivity, while the sediment samples from the Western Bay of Bengal showed high species diversity with the dominance of Gepharocapsa oceanica and subdominance of Emiliana huxley, indicating high productivity. Except the biostratigraphical studies, one study is performed by Dr. Stuti Saxena with Arindam Chakravarti on the revision of stratigraphic range of Nicolithus amplificus. In this study, the occurrence of Nicolithus amplificus in the Indian Ocean, Paratethys, and Adriatic Sea have been documented for the first time. The stratigraphic range of small Nicolithus amplificus has been extended down from late Miocene Messinian to early Middle Miocene in Indian Ocean and further late Eocene in the Adriatic Sea. Thank you.